Myself, Angira Gaurav Purohit, Department of Pharmaceutics, PE Societies, Modern College of Pharmacy, Nigdi, Pune 44. In this quick review, we'll study some techniques of microencapsulation. The slides shows the technique of phase separation, coacervation and microencapsulation. The left hand side shows the steps involved in the technique. The very first step is dissolution of the coating material, generally a polymer, into aqueous or organic phase or organic solvent. Okay. Next step, into the solution of polymer, the drug is dispersed. This drug will serve as the core material for the microencapsulation. Then after, phase separation is caused by various means. When phase separation occurs, the solubility of polymer decreases. It slowly comes out from its solution and gets deposited onto the core material which is available. After some time, all polymer comes out and coats the microcapsules, coats the core material and forms the microcapsules. Then after, the step followed is hardening of the microcapsules. This can be by various methods, and then the microcapsules are obtained. If we see on the right hand side top, it shows that the two-phase system is formed into three immiscible phase system. So earlier at this time 0, when phase separation is not started, the system is two-phase, that is polymer in solution, which is first phase, and the dispersed drug is second phase. As we cause phase separation, the two-phase system transforms into three-phase system, where the first phase is the aqueous or organic solvent. Second phase is the polymer which has come out from the solution, and the third phase is the drug or the core material which is to be coated. Then after deposition of the polymer occurs, as I have explained, into the steps, and then the rigidization of microcapsules is done. Okay, the phase separation and microencapsulation can be done by various methods. It can be due to temperature change. So due to reduction in temperature, the polymer solubility decreases and the polymer comes out from the solution. It can be, phase separation can be by addition of incompatible polymer. Say a positively charged polymer is dissolved in its solvent and a negatively charged polymer is introduced, then which has more solubility, then the earlier polymer will come out from the solution and will cause microencapsulation. Next is addition of non-solvent. So here the non-solvent addition causes reduction in the solubility of the polymer, and that causes microencapsulation. It may be due to addition of salt. So salts are electrolytes. They snatch water from the polymer strand which is used to cause dissolution. So polymer comes out and causes coating of the core material, and thus the microencapsulation occurs. Polymer interactions. The two polymers, they interact to form a larger molecule. So the solubility of this newly formed polymer complex will be less than the earlier reactant polymers. So it will come out from the phase and will cause microencapsulation. If we see the diagrammatic view of the microencapsulation in the right hand side bottom, then the A diagram shows only the core material which is there in the suspension. In B, by any means the phase separation and co-adsorption of the polymer occurs. In C, the polymer starts depositing onto the core material, and D, the entire core material is uniformly covered by the polymer and the microcapsules are formed. This process can be seen under the microscope very well. Next method is solvent evaporation method. So in this method, the core material is dissolved or dispersed into the liquid manufacturing phase. Then after, the coating polymer is added as the solution form, and these two are agitated. The liquid manufacturing vehicle phase is evaporated by different methods. The method can be generally a heating method, so that it causes evaporation of the polymer solvent. So evaporation of polymer solvent causes deposition of the polymer onto the core material, and the microcapsules are formed. So thus microcapsules can be such that which may contain a solid core or the liquid core. If the core material is dissolved or dispersed into a liquid phase and the liquid droplets are coated, then the microcapsules may contain liquid core. If the core material is solid and the polymer is deposited, then the microcapsules may contain liquid core. Another methods of microencapsulations are interfacial polymerization and in situ polymerization. We'll study these two methods side by side because these two are similar, but they are different in a way where in interfacial polymerization the polymer gets deposited onto the core material, whereas in situ polymerization the polymer reactants are added to the liquid manufacturing phase. They form polymer by physical or chemical methods, and then they get deposited onto the core material. So if we see, then the monomers will be dissolved in liquid core material, and which will then be dispersed in aqueous phase containing dispersing agent in interfacial polymerization, whereas in situ polymerization this process contains no reactive agent and these are added to the core material. Okay. In interfacial polymerization, a co-reactant multifunctional amine will be added. In situ polymerization, polymerization occurs exclusively in the continuous phase and not at the interface. In interface, this results in rapid polymerization at the interface and causes formation of microcapsules. In situ polymerization, initially low molecular weight polymers will be formed and then they will get deposited onto the core material. Okay, a polyurea shell will be formed when isocyanate reacts with amine. This is an example of interfacial polymerization. And in situ polymerization, it deposits onto the surface of the dispersed phase and forms the microcapsules. Thank you.